Number 2, I have a box of mass 10 kilograms is placed on a horizontal plane. The following forces are applied to it in addition to its weight and the normal force of the surface. So these are the forces. F1 equals 20I, F2 equals minus 27I, F3 15I, and F4 2I. Number 1, or part A, they need to draw the diagram force of the box. 2, I need the acceleration of the box, and C, I need the speed after covering 2 meters. Now, let's correct A. First of all, this is the horizontal plane. I have a box. This is M equals 10 kilograms. I have, of course, the weight of this box. The weight is a force, it's a vertical force going downwards. This is W. I also have the normal force, which is a vertical force going up. This is N. And I have these 4 forces that I'm going to represent. You have to take a scale. So let's say this is 20 newtons, F1, then F3, it has to be logic. F3 and F4 equals to 2 newtons, whereas F2 equals minus 27. This is part A. Now, part B. Acceleration of the box. As we said in the previous exercise, I need the acceleration. I have a mass and I have forces. What is the relation between acceleration and forces and mass? This is Newton's second law. This law states that the net force is equal to the mass. The net force applied on a certain object is equal to the mass of this object multiplied by its acceleration. Let's find the net force. The net force is W plus N. You always have to write it as a sum of vectors in the beginning and then you replace by numbers, plus F1, plus F2, F3, F4. And as always, since it's a horizontal plane, the normal force and the weight are going to cancel each other. These two are equal to 0 Newton. Now, I'm left with sum of F. When you replace by numbers, you don't put vectors anymore. Equals F1, 20, minus 27, plus 15, plus 2. Equal, these two are 17, so you will get minus 10. This is 10 Newton. So the net force is equal to 10 Newton. Now, since I found the net force, sum F equals MA, so 10 equals, the mass given is 10, and A is the unknown, so A equals 1 meters per second square. This is the acceleration of the box. Finally, I need to find the speed after covering 2 meters. I need the speed. What I have is acceleration. What I have is, after covering 2 meters, this is the final position, or x final. So I need to find the equation that relates all 3. The equation is v final square minus v initial square equals 2a times delta x, which is in fact x final minus x initial. As I said previously, if they don't give you values for the initial, it means they are 0. This is 0, this is 0. I will replace each term by its value. This is the unknown. V final square equals 2. A is equal to 1. X final is equal to 2 minus 0. You can write it simply. So V final equals 2 times 2, 4. This is V final square, so V final equals the radical of this one equals to 2 meters per second. So this is the final velocity after covering 2 meters.